Hello, we're going to look at C++ function templates and the main lesson objectives are that at the end of this lesson, you should be able to answer the following questions. Number 1, what are function templates? Number 2, which classes can use a function template? Number 3, how to overload function templates? Number 4, how to force a function template to be called? And finally, how do function templates compare against macros? Let's begin looking at function templates. Let's look at a simple problem. We need a set of functions to return the absolute value of a number. So one solution is to write a series of overloaded functions. For example, for the integer, we can write int myAppsInt. Then we can write another version, double myAppsXXX, float myAppsXXX. So each of them returns a certain type depending on the input parameter. Now the question is, how many variants can we write? For every new object type X, for every new class, we have to write a different function. Or is there a smarter way? Can I write a single function to take care of all these jobs? That means, can I write a function which will take an unspecified type argument X and return a value of the same type? Can we write a generic function of the type myApps type X? Function templates in C++ provide the solution. Here we see a function template of a function to swap two values. Look at the syntax. The usual function is here, void swap. It takes two arguments, temp1 and temp2. They both are reference variables of an unspecified type t. And here is another variable of the unspecified type t. This unspecified type t is what is mentioned in the syntax of the first line. Here's where we write template class t, meaning that this is a function template containing an as yet undefined class t. This class t will be provided by the user in the function call. Having created these two variables of temp1 and temp2 of an unspecified type t, we can continue to use this t as a data type in the code. So here we declare a variable temp of the type t and we write the usual code for the swapping of the two variables, and that's the end of the code. Now how does this work? This works here. I have changed the function name swap because it conflicts with a internal library function of C++. We're calling it myswap here. Here's a template, the function template here with the unspecified type t out here. Here are the two variables of the type t. Here is another temporary variable of type t. Now, here's the function call. In this function call, we have used this function at three different places. First, we have declared two variables of type int and we call the function myswap, the myswap function template to swap them. We have declared two variables of the type double and we have used the myswap function template to swap them. We have declared two variables of type char and we have swapped them using this myswap. Now let's look at the code of myswap.cpp and run it and see the actual output. Here's the code of the function template myswap. Here we can see this is the comment saying that there's a function myswap, t is a generic data type, and as usual we start the code by writing #include iostream and using namespace std. That is, we are using the standard namespace. Now here's where we declare the class template. So here we write template class t, that is the class t will be the unknown class t in this function, void myswap temp1 temp2, and here's the body of the code, and let's see how we use it here. We declared variables of type int of type double, of type char. We swap the integer variables with myswap, we swap the double variables with myswap, we swap the char variables with myswap. Furthermore, here we declare two strings, hello and hi, and we swap the two string pointers also. Let's see what happens when we run this function. We'll compile it using the command g++ myswap.cpp. And we'll execute it, and you see the result that indeed here's where we see that the two integers got swapped, the two doubles got swapped, the two characters got swapped, and the two strings also got swapped. So this indeed does work. Let's go back to the PowerPoint. So we are seeing that the same function template has been called for int, double and char, and also for strings in our example. Another example of a function template here is this function template for a min function. Here the function is min1. Given two values a and b, it returns the smaller of the two. So given two arguments a and b, it returns the smaller of the two. The code is here: return if a is less than b, return a, else return b. So the return type is also of the same type t. Here the unknown type is t. Yet another example of use of this function template. Here's a function template, min1 function template. Here we are calling min1 with two integers, and here we are calling min1 with two double variables. In both of them, it will find the appropriate value using the function template. Let's look at the code. Here is the function template min1, and here it's where it's being called int a equal to min2, 3, double b, min 4.5, 2.3. Now let's go and run this code and let's see what happens. G++ min1.cpp. And it indeed returns the smaller of the two values. Another example of a function template would be a function template to calculate the absolute value of a given value. Here we write the code. Another Another example of a function template is given here. A function template to calculate the absolute value of a given value. The given parameter is a, which is of type t, and the value returned is also of type t. The code is very simple. If a is less than 0, return minus a, else return a. Function templates and user-defined types and classes. All the operators used in the function template must be supported in the user-defined type or the class. In other words, all the necessary operators must have been overloaded in the class. In addition, the necessary constructors must be available for creating temporary objects wherever necessary. What does this mean? What does this mean in practical terms? Let's look at the min1 function template. Here's the min1 function template. Takes two arguments a and b, and here's the code. So here, whatever be the type of the object a and b, we are doing an operation a less than b. That means this operation of less than should be defined for the class to which a and b belong. That means if a and b belong to a class T, this operation must be defined for the class. If it is not defined, the program will not compile. Now let's look at an actual programming example to see how it works. Here is a program called minfracbad.cpp, in which we have defined this class T and a function template min1 using the class T. Now here we also define a skeletal function fraction class fraction, which has two data members, a numerator and a denominator. It has a public constructor which takes two default values, n equal to 0 and d equal to 0. Now here I have declared two objects of the class fraction p and q, and I try to call the function template min1 on p and q. Let's see what the compiler says. G++. The compiler says that no match for the operator less than, because it tried to find this, and in that there's a code and there is no operator less than found, so therefore it could not compile. Now let's fix this. Here's the modified code, the same class fraction, but this time with a less than operator defined for the class. And as is usual with symmetric operators, we have defined it as a friend function, and we have defined it as a global operator, int operator less than compares two fractions f and g. Here's the code which compares f and g. So what we have done is we've taken the earlier code, and now for the class fraction the less than operator is defined. Now once again we try to call the min1 function template on p and q, and let's see what happens now. It compiles and gives the lesser of the two fractions. We had given 2 by 3 and 4 by 5. 2 by 3 is the smaller fraction of the two, and we get the right output. That's what we meant in the earlier slide by saying that the class must support the operations in the function template. Let's look at the other example of swap. In this, we have temp1 and temp2 of a type t. So the first thing we do is we declare a temp variable of type t. Now as you can see here, for this line of code to work, the class t must have a default constructor or a no-args constructor. Otherwise, this line of code will not compile. Similarly, here it must have an overloaded assignment operator for these three lines of code to work. So the function template mySwap will work only on a class which has number 1 a no-args constructor, number 2 an overloaded assignment operator. Otherwise it will not work. Let's look at the class requirements of the function template myApps. In myApps we are using two operators. One is the comparison against 0. So this could be either some kind of a function which compares the object of the class t against 0, or it should have some kind of a conversion function to convert a 0 to a type t, and along with the function overloaded for the less than operator. It also needs to have the overloaded unary minus operator, because here we write minus a. So what do we assume out here? That class t has a constructor to convert 0 to type t, or it has a function which can compare against integers. The less than operator is defined for the class T. The unary negation is defined for the class T. Let's review what we learned. The template keyword specifies the function as a template function. Writing a class T after the keyword template specifies that the function takes a generic type argument T. A template function is to construct a family of functions working in the same fashion. They're all similar functions with the same code but using different types. They're also known as parameterized or as generic functions. Each template is a skeleton for a set of similar functions working on different types of data. The data is what is specified in the parameterized type. The code contains one or more unspecified data types which will be specified in the caller code. The template becomes a real function when it's invoked or instantiated with a specific data type. In the user program, the template will be called with a specified data type. We can replace many overloaded functions with a single function template. And a template function in all other respects works like an ordinary function. It can be preceded by the normal modifiers of inline, extern, static, etc. When do function templates need help? Let's see here. Here's our min1 function template. What happens if we pass two strings to the function? They will simply compare the pointer values of x and y and not perform a lexicographic comparison. So, what can we do here? We can add a specialized or an overloaded version of min for strings. So, here's a min1 function, which is a function template. Here's a min1 function, which is specialized for strings only. It compares two strings using the strcmp function. So now we have overloaded the class template with another version of the function which takes a char star as input and gives a char star value as return. So we can overload a function template with a function of same name. At the time of calling the function, the compiler decides the best suited function. If there is an exact match in the data type, then instead of the function template, the ordinary function is called. That means the specific function is given first preference as compared to the function template. However, if you do want to use the function template even when a specific function exists, we can force it by appending this symbol, the template symbol, to the function call. Let's look at an example. Here's our min1 function template. Here's our min1 function overloaded for the type double. So here we make a call of min1 with two integer variables. Since there is no specific version with integer type, it calls the function template. So this one calls the function template. Next, we call the double version min1 with two arguments of the type double. Now it has two choices, either to choose the specific version for the type double or to call the class template. The preference is for the specific version. So this function call calls the specific version for the type double. However, we can force it to call the function template by writing min1 and the template symbol here. This one forces it to call the template class as shown out here. Let's see this in the example min2.cpp. Here's our template class min1. Here's our specific type for the type double. Here it prints template version and does the work. It prints the double version and does the work. Now as we saw the code, this one min1 2 3 calls the template with the integer values. Min1 the double calls the specific double version, and min1 with this symbol out here calls the template function by force. Let's run it and see what happens. G++ min2.cpp. You see that the last one is a force call to the template version with arguments of the type double, as we had seen in the code. The use of this operator here with the function name forced it to call the template instead of the specific version. Let's look at how function templates compare against macros. Template functions and macros work in very different manners. Macros are taken care by text substitution or text pre-processing, so debugging of macros is tough. A macro is essentially typeless. For example, if we define a macro called max A and B, the above macro may allow comparison of different types of data. There is no way to ensure that A and B are data types of the same type. So function templates perform strong type checking, whereas macros do not perform type checking. So function template gives us the same kind of benefits as macros, but with strong typing. And strong typing is an essential feature of all object-oriented programming languages. Thanks. If you have any comments and queries, you can send them to my email ID ravipireddy@gmail.com. Please refer to C++ function templates video number 1. I hope you enjoyed it. Thank you very much.